Triangles.
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 Triangles. Triangles.
Okay, so this is a right triangle. Right triangles are a special type of triangle that contain one right angle. They only contain one right angle because you can't have more than one angle of 90 degrees in a triangle, as those would automatically add up to greater than 180 degrees, which is impossible. A right angle is, as such, one that is 90 degrees. It is designated by the square in the bottom left corner of the triangle. This doesn't depend on orientation of the triangle, meaning if I turn it as such, it now becomes the bottom right corner of the triangle. So the right angle is just any angle with 90 degrees. Right triangle sides are connected by a special relationship called the Pythagorean Theorem. Their lengths, a, b, and c, are connected through this formula. A squared plus b squared equals c squared. A and b in this diagram are both called legs of the triangle. A and b are the shortest sides of the triangle. It doesn't matter how long or short they are as long as they're both shorter than side c. Side c is called the hypotenuse of the triangle. Now in any triangle, the size of the angle corresponds to the length of the opposite side. Meaning, if this angle is smaller than this angle, then this side will be shorter than this side, because this side is opposite this angle and will thus be smaller. As such, these two angles are acute, meaning less than 90 degrees, and will have shorter sides than the hypotenuse, which is opposite a 90-degree angle. So the length of the legs squared added up equals the length of the hypotenuse squared. There are special cases of right triangles, and as such we call them special right triangles. One case of these is called a 45-45-90 triangle. It is called this because of its angles, which are 90 degrees, obviously because it is a right triangle and has a 90-degree angle, and the other two are both 45 degrees. To check that this works, we add them up. 45 plus 45 is 90, plus 90 is 180. All triangles have 180 degrees, so this works. One special thing about this triangle is that it is isosceles, meaning two of its sides are congruent. This is because these are the congruent sides. This is because two of the angles are congruent. Just as I have said that smaller angles produce shorter opposite sides, these two angles are equal, so their opposite sides should also be equal, and this is true. Now, instead of calling them A, B, and C, we'll call one of the legs x, just as a variable. Because it is isosceles, the other leg is automatically also x. Temporarily, we'll still call the hypotenuse c, just to show what the relationship is between these three sides. The Pythagorean Theorem states that the relationship between the three sides of a right triangle is a squared plus b squared equals c squared. Now, because both of the legs instead of a and b are x, we'll call these x squared plus x squared equals c squared, just to substitute in the correct values. Because these are like terms, we can collect them into simply 2x squared equals c squared. Now, as an algebraic operation, we'll take the square root of both sides. Because in algebra, you can do the same thing to both sides, and it'll be okay. Root c squared simplifies to just c, so we get this simplification. You can separate square roots into separate multiplication processes. So you actually get square root 2 times square root x squared equals c. Now we can simplify square root of x squared into just x. So you end up with c equaling square root 2 times x, which is the side of any leg. Thus, we end up with a relationship between the sides of x to root 2 times x. Or, simplified, 1 to 1 to root 2 as a ratio. This applies for any value of x, meaning if the value of the leg is 1, the value of c, the hypotenuse, will be root 2. If the value of x is 3, then it'll be 3 times root 2. And this applies for any units also. So 2 centimeters, 2 centimeters, 2 root 2 centimeters. So another sort of special right triangle is a 30-60-90 right triangle, so called, again, because of its angles. 90 degrees automatically, because it's a right triangle, and then 30 degrees and 60 degrees. 30 plus 60 is 90, plus 90 is 180, and so it works out. Now here we're gonna call the short side again x instead of a, b, and c. Now here you have to do a little bit of just assumption and memorizing. The longer side, the hypotenuse, is 2x. It is 2 times the length of the shortest side. So the longest side, the hypotenuse, is 2 times the length of the shortest side. And the shortest side is, of course, opposite 30 degrees, because, as I've already said, shorter sides are opposite smaller angles. 30 degrees is the smallest angle, so it's opposite the shortest side. Now, we're going to do a squared plus b squared plus c equals c squared again, but instead we're leaving b as b, and we're calling a x, and we're calling c 2x. So now we substitute in, and we get x squared plus b squared equals 2x squared. Now you have to remember that 2x has to be in the parentheses. Now you simplify, and you get x squared plus b squared equals 4x squared when you distribute the squared throughout both parts of the multiplication. Now you carry over one of the x squareds over to the other side. You subtract x squared from 4x squared, and you get 3x squared. You can do this because it's a normal algebraic operation. Now you take the square root of both sides, and this would be square root of b squared, because, once again, with algebra you can do the same thing to both sides. And, once again, you can separate the square root into 2 separate multiplication problems. So, square root of 3x squared becomes square root of 3 times square root of x squared, and square root of x squared automatically becomes x. So you end up with b equals square root 3x. So, as a result, the ratio between the sides is x to root 3 times x to 2x. Root 3x is then the medium side, slightly longer than x, slightly shorter than 2x. This ratio can be simplified to 1 to root 3 to 2. Once again, the x's are just there to show you that it works for any x. It can be 2 to root 3 times 2 to 2 times 2, which is 4, etc. And once again, works for any units. Now, here's a table of all of the special right triangles we've learned, plus several more. The first one is 1 to 1 to root 2. That was the 45, 45, 90 that we learned. Then 1 root 3, 2, which is the 30, 60, 90 that we learned. Now, here's a list of several more. 3, 4, 5, which comes up very often, 5, 12, 13, 7, 24, 25, etc. Now note that just as the 45, 45, 90, and 30, 60, 90, all of these actually work for all multiples of the numbers. So 3, 4, 5 also works for 3 times 2, 4 times 2, 5 times 2, or 6, 8, 10. Likewise, it works for 9, 12, 15, so on and so forth. The same thing applies to every single one of these on the table. So really, it doesn't say 7, 24, 25, it says 7x, 24x, 25x. Now, while the last one on the list, 8, 15, 17, is just a neat one to remember, the other ones on this list, 3, 4, 5, 5, 12, 13, 7, 24, 25, 9, 40, 41, and 11, 60, 61, all follow a special pattern. The pattern is demonstrated in this formula here, x squared minus 1 over 2. What you do is you pick any odd number above 1. So anywhere from 3, 5, 7, 9, 11, 27, 41, any odd number. And you choose that number to be x. You choose that number to be x, and you plug it into this formula, x squared minus 1 over 2. That produces the second number in the list, which is, as an example, you get 9. 9 squared minus 1 over 2, which ends up as 81 minus 1 over 2, which is 80 over 2, which is 40. As such, we have 9, 40, 41. The third number can be solved for by Pythagorean Theorem, but if you notice, there's a pattern. In all of these types that follow this formula, the third number is 1 greater than the second number, which can be demonstrated by the formula x squared plus 1 over 2, instead of minus 1 over 2. Great. The reason why this formula works is because x squared minus 1 over 2, when you distribute the division by 2, becomes x squared minus 1/2. When you distribute when you distribute the x squared plus 1 over 2, it becomes x squared plus 1/2. Just as the x squared minus 1 over 2 becomes x squared over 2 minus 1/2. Thus, to go from this formula to this formula, you simply add 1. Minus 1/2 plus 1 equals plus 1/2. And this formula, again, works for any odd number.
So just to review, the special right triangles are 1,
1,
Root 2,
1,
root 3,
2,
3,
4,
5,
5,
12,
13,
7,
24,
25,
8,
15,
17,
9,
40,
41,
and 11.
60,
61.
Thanks for watching!